Hi students, this is Alex here. In this video, we are going to derive the Fourier expansion for the given function f of x, which is root of 1 minus cos x in 0, 2 pi. And also we are going to deduce summation n is equal to 1 to infinity 1 by 4 n square minus 1 equal to 1 by 2. In the first part, we are going to write the Fourier series expansion formula. F of x is a naught by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. Now to find a naught, we use 1 by pi integral 0 to 2 pi f of x dx, and this is 1 by pi integral 0 to 2 pi f of x is root 1 minus cos x, then we have dx. And there is a trigonometric formula for 1 minus cos x. We are going to apply that here. That is 2 sin square x by 2 dx. Now I am going to take the square root separately for 2. So that gives root 2, and separately for sin square x by 2, that gives sin x by 2, then we have dx. Now let's integrate this. Outside we have root 2 by pi. Integration of sin x by 2 is minus cos x by 2 by 1 by 2, and we have the limit 0 to 2 pi. And this 2 will be carried to the numerator. So 2 root 2 by pi, and we can take the minus sign here. So we left with only cos x by 2, and I have to apply the limit 0 to 2 pi. Now using the upper limit, it will become cos 2 pi by 2 minus cos 0. And this becomes cos pi is minus 1. So this is minus 1, again there is a minus 1 here. Cos 0 is 1, but there is a minus sign. Anyway, I'll write it neatly in the next step. So minus 2 root 2 by pi minus 1, which is minus 2 root 2 by pi into minus 2. You can cancel this. So the value of a naught is 4 root 2 by pi. Now coming to an, the formula is 1 by pi integral 0 to 2 pi f of x into cos nx dx. And f of x is root 1 minus cos x by applying trigonometric formula, which is 2 sin square x by 2. Taking root separately, it is root 2 into sin x by 2. So this is 1 by pi integral 0 to 2 pi root 2 sin x by 2 into cos nx dx. So here we take root 2 common, that is outside the integral. So root 2 by pi integral 0 to 2 pi. Let's have cos nx first, then into sin x by 2 dx. We are going to apply a trigonometric formula to convert this product as a sum of the difference. So we have a formula cos x into sin y, that becomes half sine of sum of the angles. So it is n plus 1 by 2x, then minus sine of difference of the angle, n minus 1 by 2x. So let's substitute here. So it is root 2 by pi integral 0 to 2 pi, and 1 by 2 can be taken outside. So 1 by 2 is here, and we left with sine of n plus half x minus sine of n minus half x dx. Now this is root 2 by 2 pi. On integration, we get minus cos n plus half x by n plus half minus of minus plus, and this becomes cos n minus 1 by 2 into x by n minus 1 by 2, and we have limit from 0 to 2 pi. Let's substitute the upper limit. So this upper limit will become minus cos n plus half into 2 pi by n plus half, then plus cos n minus half into 2 pi by n minus half. Then when I put minus, lower limit, cos 0 is 1 and there's a minus sign, so minus 1 by n plus half plus 1 by n minus half. Now cos n pi is minus 1 power n. So if we apply that formula for this separately and for this separately, so actually we don't need this formula because it is already a 2 pi. So cos 2 pi is 1 and we have a multiple n plus half and n minus half still, but again depends upon the value of n, this keeps changing, so it is better to use a formula. Let's write here, that is cos of, let's multiply this 2 inside, so this will become 2n plus half into 2, 2 gets cancelled, so 1, so we get 2n plus 1 pi. In the same way, this is cos of 2n minus 1 pi. So using this formula, this will become minus 1 power 2n plus 1 and minus 1 power 2n minus 1. So again let's rewrite the steps from the beginning. So we have root 2 by 2 pi minus of minus 1 whole power 2n plus 1 by n plus half here. Then the second term is plus minus 1 whole power 2n minus 1 by n minus half. Then again we take this minus sign inside of each, so it will become plus 1 by n plus half minus 1 by n minus half. So here we find 2n plus 1 and 2n minus 1. Whatever I take n value, these two terms always gives odd number. If I take n as 1, then this will become 3. If I take n as 2, this will become 5. If I take n as 3, it will become 7. So when I take values of n, I am always getting 2n plus 1 as odd. And even 2n minus 1 is also odd. So when I have minus 1 power odd number, it is always minus 1, even here. So once again, applying it clearly, we get root 2 by 2 pi, and there is a minus sign, and this will be minus 1, so we can make it as a plus 1 by n plus half, and this will be minus 1 because minus 1 power odd number is minus 1. So this will be minus 1 by n minus half, again plus 1 by n plus half minus 1 by n minus half. So we find these two terms are same and these two terms are same. We are going to add. So root 2 by 2 pi. This is 2 by n plus half minus 2 by n minus half. Let's take the 2 common. from the numerator. So 1 by n plus half minus 1 by n minus half. We can cancel this. We are going to take LCM here. So root 2 by pi. LCM is n plus half into n minus half. So here n minus half minus of n plus half. So minus n minus half. I have taken the minus sign inside. So these two gets cancelled. And now minus of is minus 1. So root 2 by pi into minus 1 by, let's write it neatly here. An is root 2 by pi, minus of minus half is minus 1. I take minus here, and this is a plus b into a minus b. So n square minus 1 by 2 whole square is 1 by 4. Again, we can take LCM. So if I take LCM, it is going to be 4n square minus 1 by 4, and then by 4 can be taken to the numerator. Therefore, we got an as minus 4 root 2 by pi into 4n square minus 1. Now, in the same way, we are going to find Bn. So the formula for Bn is 1 by pi integral 0 to 2 pi f of x into sin nx dx. And already f of x is 1 minus cos x we know. This by applying formula 2 sin square x by 2 by taking separate square root. So root 2 and sin x by 2. So Bn becomes 1 by pi integral 0 to 2 pi root 2 sin x by 2 into sin nx dx. So here we are going to apply formula for sin nx into sin x by 2. From this product we are going to convert into sum or difference. So the formula is minus half cos of n plus half into x minus cos of difference of the angle n minus half into x. So coming to Bn, this will be root 2 by pi integral 0 to 2 pi, and that's a minus 1 by 2. So we keep minus here and 2 here. Now it is cos of n plus half x minus cos of n minus half x dx. When we integrate, cos becomes sin of n plus half x by n plus half minus sin of n minus half x by n minus half. We have limit from 0 to 2 pi. When I put 2 pi for sine, it will become 0, and when I put 0 for sine, it will become 0. So after applying the limit, totally this term becomes 0. So Bn is 0. So now coming to f of x, first is a0 by 2. The value of a0 is 4 root 2 by pi. So we have 4 root 2 by pi. Let's write it here. 4 root 2 by pi, but it is a0 by 2. So let's put 2 here. Plus summation n equal to 1 to infinity an. We have an which is minus 4 root 2 by pi minus 4 root 2 by pi into 4n square minus 1. That is an into cos nx. And since Bn is 0, the last term will be 0. On rewriting further, we are going to get f of x equal to, we can cancel this. So 2 root 2 by pi, and we can take the numbers are the constant outside. So 4 root 2 by pi summation n equal to 1 to infinity. We have cos nx by 4n square minus 1. This is our required Fourier expansion for the given function. In the question, there is also another part. We have to deduce the value of this. For that, we are going to take x equal to 0. So we are going to find f of 0. F of x is root of 1 minus cos x. So now it is root of 1 minus cos 0. Cos 0 is 1. So root 1 minus 1, which is 0. So here 0 equal to 2 root 2 by pi minus 4 root 2 by pi summation n equal to 1 to infinity. Cos 0 is 1 and we have 4n square minus 1. And this negative term we are going to take to the other side. So 4 root 2 by pi summation n equal to 1 to infinity 1 by 4n square minus 1 equal to this remaining 2 root 2 by pi. So both the sides root 2 by pi we can cancel and this 4 will be taken to the other side denominator. So summation n equal to 1 to infinity 1 by 4n square minus 1 becomes 2 by 4. So we can cancel by 2 tables, so we get 1 by 2. Therefore, sigma n equal to 1 to infinity 1 by 4n square minus 1 equal to 1 by 2. So in the question they have given sigma n is equal to 1 to infinity is 1 by 4n square minus 1 is 1 by 2. Thus we got it here.